All right, this video is a review for our test over compositions, inverses, and absolute value. So y'all just have to bear with me. I'm gonna have to zoom in on these questions, but let's take a look at number one. This one is asking you to subtract f of x minus h of x. Okay, so we have f of x up here and we have h of x here. So I'm just go ahead and set that up as a subtraction problem. By the way, again, this is f of x minus h of x. All right, so if we work that out, we have 7x minus 9. And then we are subtracting all of h of x. So I want to be sure to put it in parentheses, the square root of x plus 8. Okay, we can put them both in parentheses if you would like. I just want to ensure that you are subtracting both of these terms. Now, when we do that, all we're really looking for is like terms. But if I go ahead and just work it all out, it's 7x minus 9, the square root of x, and then minus 8, okay? And when we work all that out, or really we're just looking for like terms, which all we really have is this minus 9 and this minus 8. So when we put all that together, your answer would be 7x minus 17 minus the square root of x, okay? And we haven't seen a lot of those, but that's what that would be. You're talking about like terms, okay? Now, as far as your domain, you want to consider, like most of our domain is all real numbers, but some cases we can't enter, certain values. And for this one, because we have the square root of x, we cannot enter a negative number because you cannot find the square root of a negative number. So our domain in interval notation, which is what it's asking for, is going to be from 0, which is included because we can find the square root of 0, all the way up to infinity. So it would be 0 to infinity, and then our infinity would have a bracket like that. So from 0 to infinity. All right, let's go to number 2. All right, so for this one, we have k times f of x, or another way of writing that out is k of x times f of x, okay? So our k of x is x squared minus 5x plus 3, and they're multiplying all of that times f of x, and f of x is 7x minus 9, so 7x minus 9. So however you want to work this out, you have to multiply all of these terms times each other. So I'm going to set it up like this. I'm going to do 7x times x squared minus 5x plus 3. And then I have this minus 9. Again, that's this term here, minus 9 times all three of these. And again, you can set it up differently. It's similar to the FOIL method, but it's not really first, outside, last because we don't have a binomial times a binomial. But we have three terms. So x squared minus 5x and then plus 3. We got to multiply all those. So now I'm going to go ahead and do this multiplication. We're going to distribute these two terms to all three of these terms. And when I do that, I'm going to get 7x to the third minus 35x squared plus 21x, okay? And then over here, I'm going to have minus 9x squared plus 45x and minus 27, okay? And then again, when you combine all your like terms, let me just highlight some like terms real quick. We have the minus 35 squared and the minus 9x squared. And then we also have the 21x and the 45x, okay? So our final answer would be 7x cubed minus 44x squared, and then plus 66x, and then minus 27, okay? And then again, when we consider the domain restriction, what are the values that we are not able to plug in? Well, in this one, there's no restrictions because you can cube anything, you can square anything, any of that is fine. So this is going to be all real numbers. But when we write that in interval notation, we would put negative infinity to positive infinity with our parentheses. Okay? All right. So now let's take a look at number 3. So I'm going to zoom out and then show you right here. So we have division here. Okay? So we have h of x divided by f of x. Well, let's just go ahead and write out what h of x is. So we're going to have the square root of x plus 8 divided by 7x minus 9. Okay, when we have this division, we're going to look to simplify each one of these expressions, but they really can't be simplified. So this is like a fraction that is already simplified. So we'll just consider that our answer, but then we need to consider the domain restriction. Okay, but again, we have the square root of x plus 8 divided by 7x minus 9. Okay, now this is where to consider your domain, if you have any kind of problem that has a square root value, think of our parent function square root. We know we cannot find the square root of a negative number. So we would not be able to put in any negatives. It would have to be 0 or greater. So again, I'm just going to consider the fact that the x would have to be greater than or equal to 0 for the domain restriction of the square root. Then we have the fact that this is a rational expression because we have this denominator of 7x minus 9. And remember, the parent function of a rational is 1 over x. And we know that the domain restriction is that the x cannot equal 0. Well, what we need to consider now is that we have this expression 7x minus 9. We're going to write that as an equation 7x minus 9 and set it equal to 0 and solve it for x. So plus 9 on both sides, and we get 7x equals 9. And then we would divide by 7. What we see is that our domain restriction is 9/7. Okay, so if our domain restriction is 9/7, then we have to consider that as well in our domain restriction. Now 9/7 is greater than 0, so we can use 9/7. We can use from 0 up to 9/7, which we cannot use, and then we can use 9/7 to infinity. All right, so when we look at our actual domain restriction, we can use 0, so we would use the bracket from 0, and then we don't go to infinity because we can go up to 9/7, but that would not be included. But then we would have our union, and we would have 9/7 to infinity. And that would be your domain for this one specifically. All right, now number 4. Okay, so these are our compositions. K of g of x. This is not multiplication. This does not say k of x times g of x. It says k of g of x. Okay? Now, if we had a value here for x, we'd put it into g and evaluate it, and then we put that answer into k. But now we just have our function g of x. So we're going to take g of x and plug it into k of x. Okay? So just as a reminder so you can see it, k of x is equal to x squared minus 5x plus 3. Okay? And then g of x is equal to x squared minus 4. Okay? So what we're going to do then is we're going to take the x squared minus 4, which is g of x, and plug it into k of x everywhere we see x. So we're going to rewrite it in parentheses. So what we're evaluating here then is k of g of x. So we're going to have x squared minus 4. So x squared minus 4 all squared minus 5 times x squared minus 4, and then plus 3. Now this part right here is a binomial squared. That means x squared minus 4 times x squared minus 4, and you need to use the FOIL method for that, okay? And we've used this a lot in class, but x squared minus 4 times x squared minus 4. Some of us call it the FOIL method, or maybe you use the box method, but it's the first term, x squared times x squared, which is x to the 4th. And then the outside term is 1x squared times negative 4. That's minus 4x squared. Minus 4x squared. And then when you do the inside terms, negative 4 times x squared, you get the same thing. So minus 4x squared. And then finally, when you square or multiply negative 4 times negative 4, you get plus 16. Okay? So when we keep working this out, what we're going to get is... well, we combine these like terms, right? Negative 4x squared minus 4x squared is minus 8x squared. So when we write all that out, we have x to the 4th minus 8x squared plus 16. Okay, now I'm going to take this minus 5 and distribute to both of these terms. So that's going to be minus 5x squared. And then minus 5 times minus 4 is plus 20. And then plus 3, okay? And then here we are looking for like terms. So we have a minus 8x squared and a minus 5x squared. And then the other like terms is the 16, 20, and 23. So our final answer would be x to the 4th minus 13x squared, and then plus 16, plus 20, and plus 3, that's plus 39. And this is another one where you do not have any domain restrictions. So the domain for this one would be all real numbers. And when we put that in interval notation, all real numbers is from negative infinity to positive infinity. All right, now let's go ahead and try to answer number 5. I think I have time for this one. This one says to evaluate f of h of 3. Okay, so we're going to take h of 3, or we're going to evaluate 3 in the h of x function, and then we'll plug that into f. So here's what that looks like. So the h of x function is the square root of x plus 3. So h of x equals the square root of x plus 8. So I'm going to change that then to the square root of 3 plus 8 because I'm evaluating h of 3. So I place that. Now I'm going to take this, the square root of 3 plus 8, and plug it into the f of x function, okay? And f of x is equal to 7x minus 9. So now what I'm doing is I'm going to take this square root of x plus 8 and replace it right here with the x. So that's going to look like this. 7 and then times the square root of 3 plus 8, and then bring down your minus 9, okay? So I've replaced this function in here with x. So now it's a multiplication. We're going to distribute this 7 to both of these terms, and 7 times the square root of 3, we just write that as 7 square root 3. That's a 7, by the way. 7 square root 3. And then 7 times 8 is 56, so plus 56, and then minus 9. And then when you combine these terms right here, you're going to get 7 square root 3 plus 47, okay? And then when you consider the domain restriction of this one, now this is a little odd. Like there's no real domain restriction here because there is no x. But if we were to think about the original, the h of x function, h of x has a square root in it. So we could consider the fact that you can't evaluate anything other than x has to be greater than or equal to 0. So we could write that as our domain restriction. And again, in interval notation, that would be 0 to infinity. And that will need to be the end of this part 1 video review.